In this lesson, we're going to solve absolute value inequalities word problems. So let's go ahead and review what we've learned about solving absolute value inequalities. Remember, the first step that we're going to do is we need to isolate the absolute value part. So we're going to do that by subtracting 7, and we'll have 2 times v minus 4 is going to be less than or equal to then 16. All right, and so now we have to divide by 2. And now we've got the absolute value of v minus 4 is less than or equal to 8. And this is the part where you have to determine if this is going to be an and or an or. Remember, we said less than, all right? So this is going to be an and. And so we're going to solve then by undoing the absolute value symbol and making it into sandwiching the between the inequality symbols. And then remember, we're reading this going backwards. It's going to be greater than or equal to then our negative 8. And so we're going to solve this like a compound inequality that we would as an and. And we're going to isolate the variable by adding the 4 to all the parts. And we have v, and we're going to have 12 here. We'll have less than or equal to. And then we're going to have greater than or equal to then negative 4. And so remember, if you were to graph this, you'd have the negative 4 on the left and the 12 on the right, and then it's coming together, and it would be everything then in the middle there. All right, so for the second one, notice that the absolute value is already isolated, and so we can just go ahead and determine if it's going to be an and or an or. And if this is a greater than, so greater, it's going to be an or. And that means that we're going to then, when we break it down into 2 separate inequalities, and we'll have negative 2k minus 6 is greater than 10, and we'll have negative 2k minus 6, then we have to flip the inequality sign and have negative 10. All right, so we're going to then isolate the variable by adding 6. Negative 2k is greater than 16. Now we're going to divide by a negative, and when you divide by that negative, you need to flip your sign. All right, so we have k is less than negative 8, and this is going to be an or, and then we're going to add our 6. And negative 2k is less than negative 4. And then again, we're dividing by the negative. And so if k is greater than, flip the sign, and then 2. And so k is greater than 2. And then if you were to graph this one, notice how they go into 2 separate directions. K is less than 8, negative 8, or k is greater than 2. All right, so now let's go ahead and talk about how we write the absolute value inequalities. And something that you need to know is that the absolute deviation is equal to the absolute value of x minus the given value. I kind of ran out of room there. All right, so let's go ahead and take a look. It says the absolute deviation of x and 3 is greater than 8. So we have then, remember, the absolute deviation means that you're going to have x, and because you're given the 3, remember, it's the absolute deviation is equal to x minus the given value. And if our given value is 3, we're going to minus the 3, and then that's going to be greater than 8. Now, so if we went then and we solved this is an or, greater, and so you have this x minus 3 is greater than 8, and x minus 3 is less than negative 8, and you have x is greater than 11, or x is less than -5. So let's talk about what that means here. What it means is that, so the absolute deviation, so you would have then your, the number 3 was the number that was given. And so if then it means that we would have then a 14, it's plus 11, and then we're going to have then minus 8. And that's going to get you then to a -5. All right, so now our next one, it says that we have 3 times the absolute deviation of 5 times m and 6 is less than or equal to 13. So let's go ahead and we're going to then have 3 times the absolute deviation of 5 times m and 6. Now remember, it's then going to be x, or the variable, minus the given value, and so that's going to be 6. And then that's going to be less than or equal to then 13. We would then start by solving this by isolating the absolute value, then determining if it's going to be an and or an or, and then solving the absolute value part. So I'm not going to take the time now to go and do that with all those, but right now I'm going to concentrate on just helping you write these absolute value deviation problems. All right, so question number 3, we have the absolute value, or absolute deviation of 2 times w and 1 is less than 11. So we're going to write that as 2 times the absolute value, or the absolute deviation of 2 times w and 1, remember it's minus then 1, is going to be less than 11. And then we have 2 times the absolute deviation of 2 times m is greater than 12. So we have 2 less than. So we're going to have the absolute deviation of 2 times m minus 9. And then we have to minus the 2 there. That's where we got the 2 less. And then is going to be greater than 10. All right, and a college application requires a 500-word essay with an absolute deviation of at most 30 words. What are the possible numbers of words the essay can have? And so if I were to write this as the absolute deviation, I'd have x minus 500 can be at most, which would be less than or equal to 30 words. So because this is less than, this is going to be an and, I would have the x minus 500 is less than or equal to 30, and then I would have greater than or equal to then negative 30. And so on our college application then, if I added the 500, you're going to have x, and you'd have 530 words, and then greater than or equal to 470 words. So let's take a look at what it means. So you have this 500-word essay that you need to write, and it can be, you can then have, so here you're on your number line, you can have it be 30 words more, 30 words less. And so your essay could either be the 470, because that's you've got this deviation of 30. So you can have it be 470, between 470 words and 530 words. And so it can be any number. It can be 470, it can be 480, it can be 500, 520, but it cannot be less than any of those or greater than these right here. So on that number line, it would look like this. All right, number 6, it says the temperature of a swimming pool is set at 76 degrees Fahrenheit with an absolute deviation of 1.3 degrees. What are the acceptable temperatures for this pool? So let's take a look at this. We have to have it at 76 degrees with an absolute deviation of plus 1.3 or minus 1.3. So it can be anywhere in that range. And so it could be then our temperatures, if I minused, I'd have at 74.7, or if I added it, I could be at 77.3. So those would be all the acceptable ranges. So 74.7 less than or equal to then our x, or x is greater than or equal to 74.7, or less than or equal to then 77.3. So in this lesson, we took a look at how to apply the absolute deviation to real-world applications.